Okay, ladies, some people have asked for help with exercise 9D, question 9C. Now, let's say you've got two multiple choice questions. This is what this is about. And you've got 5 different possible answers, A, B, C, D, or E. If you guess, right, if you guess the answer, what's the probability that you'll get the right answer if there was one question? Girls, if there's 5 answers, so if the answers in the multiple choice are A, B, C, D, E, and you just guessed your answer, what is the probability that you will get it right? 1 out of 5. Okay, wait. But this, but Jill guesses the answers to 2 multiple choice questions with options A, B, C, D, or E. So the probability that she will guess it correct is 1 in 5. And what's the probability that she'll get it wrong? 4 out of 5. Good. Now, so the chance that she'll get it correct, her guess correct, is 1/5. The chance that she will get it wrong is 4/5. Now, let's do question C part 2 first. So, what is the chance that she will get both her answers correct? Yeah, we will end up using a tree diagram. So what's the probability that they are both correct? Now, girls, that means we want the first one correct and the second one correct. What's the chance that she'll get the first one correct, girls? What's the probability? 1, what? 1/5 times, so this is a multi-step event. So if she's getting them, look, girls, let's say the answer was, I'll just do it this way. We are going to learn how to do tree diagrams next. And then we're going to do it by counting, all right? So, and what's the chance that she'll get the second one correct? Isn't it a 1 in 5 chance as well? So she's got a 1 in 5 chance of getting each one correct. So it's 1 in 5 times 1 in 5 because she wants to get the first one correct and the second one correct. So we multiply. So it's a 1 in 25 chance. Now, you really haven't done this yet. We're really going to be doing this in tree diagrams. So this is going to be hard for you now. But let's say the answers were, so they just want you using the grid, not like this. This is harder for you. But what we're going to do, we're going to use the grid now. Let's say the answers were D and A. How many cells would have D? Let's say the answers were D and A. That for question 1, the answer was D, and question 2, the correct answer is A. How many cells will have that answer of D for question 1 and A for guess number 2? Isn't it only in one cell? So how many cells are there? 25. That's why she's got a 1 in 25 chance of getting them right. Because the correct answer will just be one, for both questions, will only be in one of these cells. So let's say, like I said, the answer was D for guess 1 and A for guess 2. It would only be in this cell. So the correct answers to both will only exist in one cell. So that's a 1 in 25 chance. All right. Now, the chance that she gets the first one correct is 1 out of 5. Yes. And the chance that she gets the second one correct is 1 out of 5. So when you want them both correct, the first one correct and the second one correct, you have to multiply the 2 probabilities. All right. So 1/5 times 1/5 is 1/25. But what's the probability that she only gets exactly one answer correct? So exactly one answer correct. Now, if she wants to just get one correct, couldn't she get the first one correct and the second one wrong? Or the first one wrong and the second one correct? Is that true? So if she gets exactly one correct, she could get the first question correct and the second question wrong. Or, so how can you get exactly one correct? Wouldn't you get the first one correct maybe and the second one wrong? Or she could get the first question what? Wrong, and the second question correct. Yes or no? How would you get, so you've got 2 questions and you want to get exactly one question right. You either get the first one right and the second one wrong, or the first one wrong and the second one right. Do you get what I'm saying? Now, If I say first question correct and second one wrong, in probability, and is always times. So probability of correct and then wrong for she's either going to get the first one correct, the second one wrong, or probability of wrong and then correct. Do you see what I'm doing or not? I'll make this smaller. Look, I know this is hard for you where we're doing it this way because we haven't learned how to do it properly. Now, what's the chance that she gets the first one correct? What is it? No. First question correct. A, B, C, D, E. One of them's right. What's the chance that she'll get it right? 1 out of 5. What's the chance that she'll get the second one wrong? Well, there's only one right answer. How many wrong answers are there? Times 4 out of 5. So that is getting the probability of the first one correct and the second one wrong. Or means plus. So we say or. What's the chance that she'll get the first one wrong? There's 4 chances out of 5 that she'll get it wrong. And what's the chance that she'll get the second question correct? There's only one right answer. See, girls, there's 4 wrong and 1 right answer. Does this... Okay? So, probability of getting exactly... Now, I'm going to move this up now. So, if we want her only getting one answer correct, she either gets the first question correct and the second one wrong, or the first question wrong and the second question correct. So what we want is the probability of correct and then wrong, or the probability of wrong and then correct for those 2 questions. Now, the probability of getting it correct is 1/5 times, because you want correct and wrong, times the chance that she'll get something wrong is 4/5, because there's 4 wrong answers out of the 5. Plus means or. You get the first one wrong, that's 4 chances out of 5 that you'll get it wrong, times the second question to get it right, there's only one right answer out of the 5. So that's 4 out of 25 plus 4 out of 25, which is 8 out of 25. Now we're going to learn how to do this on a tree diagram. It's just too hard to do it this way, and it's too hard to do it from the table like they wanted you to. So that's why we're going to move on to tree diagrams next lesson. When I do this in a tree diagram, you will find it very, very simple. So what I'm going to do a quick tree diagram for you so you get to see it. Okay, and then you'll see. All right? Sorry. You can, a tree diagram works. I think it's much easier than that table. So let's have a look. So tree diagram. If we want to do this with a tree diagram, this is how you set it up. We're going to be practicing this for a couple of lessons. I'm just going to show it to you. All right, girls, so we label it question 1. You could get it correct or wrong. And then I write the probabilities on the branches. So here's question 1. What's the chance that you get it correct? So girls, look at this. For question 1, I've got 2 options, correct or not correct, or correct and wrong. What's the probability that you will guess the right answer? There are 5 responses, 5 options. There's 1 chance out of 5 that you got the right answer. Like if your options are A, B, C, D, E, and one of them's right, don't you just have 1 chance in 5 of getting it right? So how many chances have you got to get it wrong? 4 out of 5. Watching? Question 2. So girls, it doesn't matter whether you got question 1 right or wrong. You could still get question 2 right or wrong. So from here, we continue on our tree. Correct and wrong. Correct and wrong. All right, so this is my tree diagram. First question could be correct or wrong. And then from there, we branch out again from each one. What's the chance that you get question 2 right? Isn't it just 1 in 5? What's the chance that you get question 2 wrong? There are 4 wrong answers out of 5. Yes? What's the chance that you get, again, 1 in 5 chance of getting it right? 4 in 5 chances of getting it wrong. Okay, now, the question was, what's the probability that they are both correct? Which branch do I go along? I come along, so I've got correct, correct. I could have correct and then wrong. I could have wrong and then correct, or I could get them both wrong. So that's how you read your branches. 2 C's, a C and a W and a C, and a W and a W. So if you had 2 questions in multiple choice, you could get both of them right? The first one right, the second one wrong? The first one wrong, the second one right? Or both wrong? Do you agree? All right, so what's the probability that they're both correct? You just get these two numbers and you multiply them. 1/5 times 1/5 is 1/25. Girls, what's the chance that you've got them both wrong? Which branch? Isn't that this branch? What do I multiply? Which numbers for both wrong? 4/5 times 4/5. So the chance that you'll get them both wrong, see, because there's a 4 in 5 chance in each question that you'll get it wrong, it's 4/5 times 4/5 is 16/25. Does it make sense? What is the probability that you get exactly one correct? Isn't it this one or this one? So that's when we go, well, I could have this one. How do I get to this one? What do I multiply for this one? Yeah, so you've got 1/5 times 4/5, or means plus. So it's those two. I've got that one or that one. Or means plus. And how do I do the next one? 4/5 times 1/5. And that was our answer before. 4/25 plus 4/25 was 8/25. And that's what we'll be doing next lesson. For a couple of lessons, tree diagrams. Now, tree diagrams, once you know how to draw them and write them on, they're easy. So we'll be doing that from next lesson. Exercise 9D, question 11. Let's go. So a letter is chosen at random from the word mathematician. A second letter is then chosen and placed to the right of the first letter. So what we're doing is we're picking out a letter. There it is. And there's the second one. Got it? We're picking out two letters and putting them on the table. All right. How many outcomes sit in the sample space if selections are made without replacement? So we're going to pick out the first letter and then the second letter. And we're not, so when we pick out the first letter, sometimes we pick out the first letter and put it back. That means replacing it. And then we pick out the second letter. All right, so girls, how many outcomes are in the sample space? How many letters are there? You better count them. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. It doesn't matter. So there's 13. I know there's repeated, but there are 13. Count them. 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13 letters. So 13 choices for the first letter. How many letters are left? And 12 choices for the second letter. How many outcomes do you have? See, girls, couldn't you have, this is what you could have. Watch. Mathematician. Watching. If the first letter is an M, couldn't the second letter be an A, T, H, E, M, A, T, I, C, I, A, N? And if the second letter is an A, sorry, if the first letter is an A, couldn't the second letter be an M, T, M, H, E, M, etc.? There's a lot of different possibilities. And if the third letter is a T, you would have those 12 others available. So the number of outcomes, if selections are made without replacement, that means I pick up the first card and then pick up the second card and don't put it back, is 13 lots of 12. 13 for the first card, 12 choices for the second card. What's 13 times 12? 100 and? Why am I getting two different answers being called out? 156 outcomes. Okay. Now, part 2. How many outcomes sit in the sample space if, oh, sorry, I've got it the wrong way. That's number 2. Okay, you pick up the first card. There it is. You leave it on the table. You pick up the second card. That's without replacement. Woms, if you pick up the first card, look at it, put it back, pick up the second card. What have you got? 13 for the first and 13 for the second. Sorry, didn't read it properly. So this is with replacement and the second one is without and this one was without replacing the first card. That's what they mean. So sometimes you can replace the first card and sometimes you don't. So I've got 13 choices for the first one. I decide to put the card back. I've got 13 choices for the second one if I'm doing with replacement. So that's 169. Does it make sense? All right, so do you understand what with and without replacement is? With replacement means I look at the first card, put it back, and choose again. Without replacement means I put the first card on the table, and then I've only got 12 left, and I choose another one. Okay, now it says how many of the outcomes contain the same letter if selection is made with replacement and without replacement. How many outcomes contain the same letter? So you could have an M and an M. What else? A T and a T, an I and an I. But there are 3 A's. Couldn't you have this A with that one? Or this A with that one? Does this make sense? Or this A. So I could have, look, A. I could have that one with this, that one with this, or this one with that. If you've got 2 M's, you've only got one way of having 2 M's. If you've got 2 I's, there's only one way of having 2 I's. And if you've got 2 T's, there's only one way of having 2 T's. But I could label, girls, M1 and M2. Do you know what I mean? T1 and T2. I1 and I2. A1, A2, A3. To see how many ways you could pick up doubles, just watching. I know we could have an M and an M, but couldn't you pick up M1 first and then M2? Or you could pick up M2 first and then M1. And that's why the answer's 12 and not 6. I could pick up T1 first and then T2, or I could pick up T2 and then T1. And same with I1, I2, I2, I1. But with the A's, you could have A1, A2, or A1, A3, got it? Or A2, A1, A3, A1. And then you could have A2 with A3, or A3 with A2. They're all the different ways. That's why there's 12 ways you could pick up the same cards. You could pick up this M and that M, or you could pick up that M first and then this M. You could pick up this T and then that T, or you could pick up that T first and then this T. Do you sort of get that? They're asking how many ways can you choose the same letter? Yeah. It doesn't matter. They want 2 of the same. So it doesn't matter about the E's and the N and the other letters and the C. It doesn't matter about those. We're just looking at choosing the same ones. So there are 12 ways of choosing the same with replacement. Now, girls, without replacement, if the card is not put back, good. That's without replacement, good. Because you could pick up M1, but M2 is still there. Now, with replacement, very good, girls, very good. So that's without replacement. You pick up M1, M2 could still be there. If you pick up M2, M1 could still be there. So that's without replacement. That's the answer to part 2. But with replacement, girls, you could pick up all of those. It's those 12, the above 12, plus you could do, so it's all of those, but you could pick up M1, M1, M2, M2, A1, A1, A2, A2, A3, A3, T1, T1, T2, T2, I1, I1, I2, I2. Because you're picking up the card and putting it back. Wait. No, you got A1, A1, A2, A2, A3, A3, M1, M1, M2, M2, T1, T1, T2, T2, I1, I1, I2, I2. What's that add up to? Plus, you could do, but you're putting them all back. So you could pick up two N's. N, N. You could pick up, what else? Two H's. What else? You could pick up two E's. And you could pick up two C's. Any other letters? C. So what do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So those 12 plus these 13 is 25. 25 ways of picking up doubles. Wow, that was a good one. Because this is why it's in the hard section. This is in the problem section. Letters are chosen from the word would without replacement. So you pick one up and you pick another one up again. You don't put it back. Is it possible to obtain O and O? What do you think? I've got would. Can you obtain an O and then another O? Yes. Chosen from the word would without replacement. Is it possible to pick up two O's? Yes. Two O's is possible because when you pick up one, there's one left. But could I pick up, without replacement, two W's? But with replacement, could I pick up two W's? Yes. So if you picked up a card and put it back, you could get two of anything. But without replacement, yes, you can still get two O's because there's two O's there. If you pick one up, there's still one there. Question 13. In a bag, there are 5 counters and they're all different colors. We've got a green, a yellow, a red, a blue, and a purple. So question 13. If one counter is drawn from the bag and replaced, so this is with replacement, and then a second counter is selected, find the probability that a green and then a blue counter is selected. So in other words, find the probability of green and then blue. All right. You don't have to. What's the chance, girls, that you'll get a green if you put your hand into that bag? And means times. So you put it back. What's the chance that you'll get a blue? Done. Or, yeah, they want it in that order. So if one counter is drawn from the bag and you put it back, and then a second counter is selected, find the probability that you get a green one first and then a blue. So it's 1/5 times 1/5, which is 1/25. In the next question, it says, if the first counter is not replaced before the second counter is selected, find the probability that you get a green and then a blue. This is without replacement. All right, you should be able to do this, girls. All right, I want you to have a go. This first one was with replacement. Chance of getting a green, then a blue. But a green and then a blue, it's very specific. A green and then a blue. Chance of a green is 1/5. I got the green, it's out. There's only 4 left. The chance of getting a blue is 1/4. So it's 1 out of 20. You're doing a 6-sided die and a 10-sided die. They've been tossed simultaneously. You want to see which total has the biggest sum. So you can put 1 to 10 downwards or across. It doesn't matter which one's which. Where do you want to go, 1 to 10, down or across? Do you want 10 down, 6 across, or 6 down, 10 across? I don't care.
10 down.
10 down, 7, 8, 9, 10, and 6 across. 1, 2, 3, 4, 5, 6. So what are they asking you? Which total sum has the highest probability? Do you know what to do now? What do? You add them all in each box. First row, what's 1 and 1? 2. 1 plus 2 is 3. 1 plus 3 is 4, and so on. Off you go. Do it. Sums have the highest probability. So what's the probability of getting a 7, a sum of 7? 6 out of, what's 10 times 6 out of 60? What's the probability of getting a sum of 8? The same. And a sum of 9 is the same. All the way up to 10, all the way up to 11. So 7, 8, 9, 10, 11, they've all got 6. No, the probability is 1/10. Which total sum has the highest probability? So 7, 8, 9, 10, and 11 have the highest probability. And all, yeah. And the probability of a sum of 7 is 1/10, same as sum of 8. Same sum of 9 is 1/10. Same sum of 10, same with the sum of 11. The others, there are only 5 in the table, or 4, or 3, or 2, or 1. Does it? Okay. Dice with 50 numbers. We're not going to write 50 numbers down and 50 across. You've just got to imagine it. You know how there's 60 numbers here in total? If I spun the spinner twice, how many numbers in total could how many outcomes in total could I get? Pretend you've got your table. 1, 2, 3, all the way up to 50. 1, 2, 3, 4, whatever, all the way down to 50. How many numbers would be in this section of the table? 50 numbers across and 50 numbers down. Go. Tell me how to do it. Guys, this is 6 times 10. What's this? 50 times 50 without a calculator. Well, what's 5 times 5? And how many zeros? 2,500 outcomes. So, stop. Find the probability that the total from the 2 spins, find the probability that the total is 100. Now, how could you get 100? Where would that occur in this table? How many times will 100 appear? Once. So it's 1 out of 2,000. 1 out of 2,500. Do you see that? Because there's only one sum of 50. What's the smallest sum going to be? 2, etc. So there'll only be one sum of 100 in that whole table. What's the probability that your sum or your total will equal 51? How can you get a 51? You can get a 1 and a... No, there are other ways too. Can't you get 2 and 49? Can we do 99 first? So let's leave that one. Probability of a total of 99. That's easier. How could you get a 99? 50 and 49. Well, won't this one be 99, but won't this one also here be 99? How many of them are there? So you could get a 49 and then a 50, or a 50 and a 49. There'll be 2 99s. Girls, just like here, see how I've got 2 15s? A 9 and a 6, or a... 9, wait. So I could have a 49 and a 50, or a 50 and a 49 for a 99. There's no other way. So probability of that, a total of 99, what is it? Anyone? 2 for 99. It's got to be 50. You can't go higher than 50. No, a 99's got to be a 50 because that's the highest you can go, and a 49. There's no other way to get 99. All right, now a total of 51 Yeah. A total of 51. You tell me how you can do it. 50 and a 1. Keep going. 49 and a 2. But couldn't we swap them around? 1 and 50. 2 and 49. So how many numbers to get to the even? Wouldn't you go to 25? Can't you go 48 and 3? Keep going. You'd stop at 25 and 25, wouldn't you? Oh, no, no, no. You'd stop at 25 and 26. Yes or no? And here you'd stop at 26 and 25. Now, you tell me how many numbers. 1, 2, 3 to 25. How many numbers? 25 numbers. Because look, 1, 2, 3 goes up to 25. Is the other one going to go down to... Yeah, it should be fine. Or you could do it this way. Actually, no, that's 25. That's 26. So you got 25 there and you got 25 here. How many chances? Not 100. 50. So do you see that, girls? A 1 with a 50, a 2 with a 49, a 3 with a 48. You don't have to write them out. You'd stop at a 25 with a 26. You look at this one going from 1 to 25. That's 25 numbers. Count on your fingers from 1 to 25. That's 25 numbers. So, and you do it this way as well. 1 to 25 is also 25 numbers. So you've got 25 and 25. That's 50 out of 2,500. Now you could do the same with a sum of 52 and 55.